Hi, so this is the first video of probably two whenever we're talking about rational expressions. So in this video, we'll talk about what a rational expression is and where it is defined. So first, a rational expression is an expression that looks like a polynomial divided by a polynomial. So whenever we see an expression like this, where it's like a big fraction that has a polynomial on top and a polynomial on the bottom, that's called a rational expression. Now remember what polynomials can be. They are just expressions that have a bunch of terms in them. So this could be 5. Okay, this could be 7. So the only restriction is that this piece cannot be 0. Okay, and so that's where we start getting to talking about where these things are defined. So a rational expression is defined for any value of x except any value making the denominator 0. So our job is to figure out where these things are defined. What's easier is figuring out where they are not defined. So what we're going to talk about is state any restrictions on the variable. Okay, and a restriction on the variable is what the variable cannot equal, probably, at least in our case, because it makes the denominator 0. So let's do an example. And just so you know, this is what the instructions will say. State any restrictions on the variable. Okay, so here's our expression, x plus 8 over x. Okay, so if we look at it, this is definitely a rational expression like we defined it earlier. This is a polynomial. This is a polynomial. Our job is to decide where this thing is defined. Again, more accurately, where is it not defined? So we're interested in this piece right here. That's our denominator. And we know our denominator cannot be 0. So we're going to find where x equals 0. Well, this one's pretty easy because x equals 0. So the denominator is going to be 0 when x takes on the value 0. Normally we'd have an equation to solve here, and we will in the next section, in the next example and the next example after that. But in this case, we know that if x is 0, we're in trouble. We'd be okay in the numerator because 0 plus 8 is 8, and that's fine. But in the denominator, we would just have a 0 down here. So the restriction on this expression is that x cannot be 0. Again, because if x were 0, we would have something that's undefined here. We would have a 0 in the denominator, and that's against the rules. Same idea as when we were finding slope and the denominator of the slope was 0, the slope was undefined. If the denominator here is 0, the expression is undefined. Okay, so again, usually you have more going on in the denominator than just x. So let's see what happens in that case. So here's b. Again, definitely a rational expression here because this is a polynomial and this is a polynomial. Our job is to decide what restrictions do we have on the variable to make sure this piece of the expression is never 0. So this is what we're looking at here. We want to find where that piece is 0 because we know that's where we're in trouble. So wherever this happens, we need to make sure x cannot equal that number because that makes the denominator 0. So let's solve this. Let's find out if 2x plus 1 equals 0, what does that mean about x? Because that's what we're really concerned with, the value of this variable. So let's solve this equation. So we would subtract 1 on both sides, and we would divide both sides by 2. So what we just saw is that for this piece of the expression to be 0, x would have to be negative 1/2. We just saw that because we made that part equal to 0 and then solved the equation. So what this tells us is that this value is actually bad news. If we were to put negative 1/2 into this expression, we just found out it makes the denominator 0. So the restriction is that x cannot be negative 1/2. All other values are allowed except negative 1/2 because that would make the denominator 0, which would make the expression undefined. Okay, the only difference you'll see in these problems is that the denominator might get a little bit more complicated to solve. Or I guess setting the denominator equal to 0 might make it a little bit more complicated to solve. But we're still doing the same basic thing. So let's look at this one. All right, still, polynomial divided by a polynomial, this is a rational expression. Our job, though, is to figure out where this thing is 0 so we can restrict those values of x from being plugged in. So that's what we're going to find out. Let's find out where the denominator is 0. Okay, this should look familiar from the last video because this isn't just a linear equation that's real quick and easy to solve. This one has a 2 in it. This has a power of 2 in it. So we're going to have to solve this. Only way we know how to do this is by factoring. So one side has to be 0, it already is, and we try to factor the other side. And we notice, I got ahead of myself, but we notice each one of these contains a factor of x. So let's factor out x. And the leftovers are x minus 4. Now we have two factors multiplied together and they equal 0. So now what we're allowed to do is take each part of that, each factor, and set it equal to 0. Well, this piece is done. And to solve this piece is pretty quick. We add 4 on both sides. But what we see now is now there are two values of x that will make this thing 0. 0 and 4. So these are the two restrictions on the variable here. If x is 0, our denominator is 0. Bad news. If x is 4, our denominator is 4. Bad news. So the restrictions are x cannot equal 0, and you could just put a comma here, or 4. And that would be our answer. Okay. Look at a couple more that make us factor, and then just one to look out for. Okay, so here's our expression. This is D. All right, again, definitely a rational expression. Here's a polynomial, here's a polynomial. We don't so much care about this one whenever we are defining these things. We really care about this piece. We need to find out where that equals 0 so we can restrict it out of our values of x. Again, this is one that looks kind of like the last one. We have an x squared here, so we can't just real quick solve it like a linear equation. This one has to be solved by factoring. So we can solve this one. It's a trinomial with a leading coefficient of 1. So we know right away what the factors will look like. Right away. And then we look at -2 and 1 because we need to have two numbers with a product of -2 and a sum of +1. Okay, well, the only two factors of -2 would be, well, and we know they have to have opposite signs, and the bigger number has to be positive. So it looks like we're looking at 2 and -1. Okay, so those are the two numbers in our factors. Okay, so now that it's factored, we know how to find the solutions to this equation. Each factor gets set equal to 0, and we solve the little linear equations. Subtract 2 on both sides, and add 1 on both sides. Okay, so we feel pretty good because we're almost done. Almost done. We solved a quadratic equation, but the reason why we don't feel great, I guess, is because we're not totally done. We just came up with some bad news. These are the two values of x we are not allowed to put into this equation, or I'm sorry, to this expression. So our restrictions are x cannot be -2, x cannot be 1. Why? Well, if we plug those in, we just found that those are the two places the denominator is 0. That's not allowed. So those are our restrictions, -2 and +1. Another one just going to kind of make us recall certain factorizations. Remember what we said at the beginning? Even just a number counts as a polynomial. So this still counts as a rational expression, even though we don't have any variables in the numerator. We're still, though, interested in only this piece to talk about where this is defined, or rather undefined. So what we're looking for is where we get into trouble, and this is trouble. The denominator is not allowed to be 0, so we've got to figure out where this happens. If we think back on solving by factoring, we're going to want to factor this left-hand side. Factoring the left-hand side can be done by difference of squares, right? X squared is x squared. 1 is 1 squared. So we know what our factors are going to look like. The sum times the difference. Each one of these can be set equal to 0. And we solve each of the little equations. And we get x equals -1 and x equals +1. Okay, so these are the two places where the denominator equals 0. So these are the two places we're not allowed to substitute in for x up here. So our restrictions are that x does not equal -1, x does not equal +1. So we have two restrictions again. Okay, so one more example here. Okay. What if we have an expression like this? We're supposed to be finding restrictions on the variable, so we're supposed to be finding where this thing is 0 to kick those values out of the things we're allowed to substitute in for x. So our job is to solve this equation. Well, we could try to solve by factoring, and it's only two terms, so we try greatest common factor, but there isn't one. We try difference of squares, but this is not a difference. This is a sum of squares, and we looked at it in that section that this does not factor. It doesn't factor, and even if you try to subtract 25 on both sides, we'd end up in this boat. And we know that that can never happen, right? Because we can never square something and get a negative number. So if you're ever in this situation where the equation that you are trying to solve, or at least this part, doesn't factor, and there isn't any solution to this equation, what it means is that there is no restriction on the variable. This thing has no solution, which means there's nothing you could put in for x that would make this happen. So there is no restriction. There is nothing you could put in for x that would cause the denominator to be 0. Sometimes that happens, especially when we just have a number down here. Like if our denominator were 5, for instance, 5 will never be 0. So there's nothing you could substitute in for x that would cause the denominator to be 0. Okay, so that's the end of this one. Next, watch simplifying rational expressions.